But our topic today are the testing monitoring receiver. We started with the first product, which was called IDA. Here you see the IDA 2, which was, I believe, also the first product, handheld product, which has an IQ analyzer on board. It still exists also as a remote unit. The second family now is the SignalShark family. You can see three different types of SignalShark: the handheld device, the remote device, and the outdoor device. All three have the same RF core inside, so the same fantastic values regarding intermodulations, noise, and so on. And all three units have a Windows 10 PC on board. And we see a little bit later that this is also a big advantage to customize the product to your demands. Yeah, as I mentioned, handheld, remote, outdoor unit, depending on where you need it. For manual searching for interferers, we have those handheld antennas, and very special, we also have automatic antennas which you can mount, for example, onto a rooftop or on the rooftop of a car and drive around. Okay, but we will see all these things a little bit later. Let's go into the challenges of interference hunting. Okay, so one challenge is signal properties, and this is something we don't have under control. Okay, today we will see some videos which I produced with BCCH, for example, from a base station, so it's a little bit more marketing. But if you like to see real interference hunting, go to our YouTube channel, and there you can see, for example, hunting for a GSM jammer, not GSM, GPS jammer. Okay, this was a real case, and you can see how easy it is, or it can be. So normally you have no knowledge about the signal itself when you start a real interference finding. Many times the power of the interferer is very, very low at your starting point. It can be unstable in power, unstable in frequency. It can be intermittent. Sometimes only it's happening for some minutes during a day. So this can be quite boring. And yeah, these are the typical challenges you are facing. And during the webinar, I would like to go through all these topics and show you where we can help a little bit. Okay, so the reception conditions are also can be very challenging because normally interference don't happen inside of a desert. They happen in urban cities, in urban areas, and there we have tons of reflections. Every building is reflecting and so on. And there to distinguish between an interferer and the a reflection of the interferer can be quite difficult. Here we can help a lot by making very fast measurements and the heat map, the statistical process. Also, we have a lot of noise inside of cities as we have tons of different transmitters inside of a city. And last but not least, your working conditions may be also a little challenge because you are not any longer maybe a team, you are alone. Maybe you are not the right one for mobile phone systems. You are under time pressure. You don't have your company car, you have a rental car, and so on. Here, I can also show you some things where we can help you. Okay? But let's go through this presentation by the different phases of interference hunting. So first of all, the system setup, the signal detection, afterwards the signal analysis, automatic location by car, manual location on foot, and finally the documentation of it. So we can't go into a very deep details during this webinar, but I will try to show you some things, and please go to our YouTube channel. There are much more videos available for interference hunting. So interference hunting phase one is the system setup. So how to mount, for example, an automatic antenna onto a car. And here we prepared a little video which happened during summertime, as you can see. And I have two big cases inside of the trunk. One is for the automatic antenna, And those cases are stable enough that you can even check them in and that you can fly by airplane to your destination where you have to do your job. I drop the cable into the car so that the end connector doesn't get dirty. And what you now need are some long arms, which I have. And then you can see the Mac mount is already pre-mounted on the automatic antenna, and clack, the antenna is now fixed onto the rooftop. You can do a realignment. You can lift it again and maybe align it a little bit better. So it's mounted on the rooftop. And we also say, please also use a safety belt in terms of an accident that the antenna stays with the car. Please think also about the protection of the color of or the paint of your car and also of the cable. And the only thing you have to do then is to connect the antenna to the SignalShark. And here we just connecting the end connector, here the digital connector, now the second connector, and now you are ready to go. Switch on the instrument. One thing is missing here inside of the video, the connection to the car charger of the car. So there is also a car charger as accessory available. And if you go out later on with the SignalShark, the batteries should be full. Don't worry about batteries inside the automatic antenna. There is no battery inside. It's fully powered by the basic unit here. So you only have to control one battery. And with fully charged battery plus automatic antenna, the complete system runs around about 2.5 hours. The batteries for sure are hot swappable, so even during working you can exchange one of the two batteries easily. We have external chargers, so everything is available that you can measure as long as needed. So coming to the next point, to the signal detection, and here I don't go directly into traditional ways of showing how the signals are measured. I go directly into the IQ Analyzer. Here we see some examples for external radio interferers. So for example, I mentioned it already, jamming products, incorrect tune, CCTV. So there are tons of different sources, and normally you don't know exactly what you will see. You have already some information by the frequency, so which service is disturbed. Is it, for example, FM radio which is disturbed? Then you know the frequency range, and by the guy or the listener to FM radio who has reported this major effect, you have already a little bit of the location where it happened. So today we have a special topic. This is a signal under signal, and normally you have those traditional tools for finding interference inside of a spectrum, which are called spectrum in a scan spectrum. You have the real-time spectrum, you have the spectrum view, and for signals under signals, you have the persistence view. You can see it here already on the screen of the SignalShark. Here we have a mobile phone systems, and you can see here is an interferer below it. On the traditional spectrum analyzer, you will not see it, but by persistence you can see it. And today I would like to show you a second way how you can show such an interferer. Why is it today more important than yesterday? Because 20 years ago we had, for example, FM radio or GSM mobile communication. So there every station has exclusive frequency, and the service was plus minus small band only. Okay, so many times it was just possible to distinguish between wanted and unwanted signals just by the frequency. Today, when we talk about 5G, for example, we are expecting bandwidth up to 400 megahertz. And if there is an interferer under it, it's very hard to find it. And as an additional challenge, we have the problem that today all systems are operating at the same frequency. So we really need something to look under the signal, because there is something under it we cannot be sure that it's looking over it, then it's easy. But normally it's under it, and then we have a real challenge to find it. So here you can see, for example, a Wi-Fi system, Wi-Fi signal in the persistence view, and parallel we also have a fast spectrogram. But the spectrogram on a real-time analyzer is sometimes not fast enough. That's why we introduced already in the IDA the so-called IQ Analyzer, which gives us the replay of IQ data without any data compression. And then you will have the full resolution inside of a spectrogram, fast enough to look into the framing structure of a communication system. So IDA2 was the first instrument with the IQ Analyzer, and I believe it was even the first instrument, handheld instrument receiver on the market who has an IQ Analyzer on board. Today, we have it also in the SignalShark. So there's also an IQ Analyzer available for it. And this is what I want to show you now with SignalShark. Before we go into the details, I would like to show you a little bit what is the difference between a spectrogram in traditional spectrum analysis or real-time spectrum analysis and the IQ Analyzer. So when we look into a real-time spectrum analyzer, like the SignalShark, the SignalShark can produce 1.6 million spectrum per second. So it means 625 nanoseconds, and then the next spectrum is coming. So this is much too much information for a display, for our eyes, for our brain. So we need something which is compressing those data. Otherwise, we are lost. And the compressor is called measurement time inside of a real-time spectrum analyzer. So the compressor is, or the measurement time is compressing data, so means we are losing information, we are losing time information, not amplitude information, but we are losing time resolution. And in the display of the spectrum, it makes sense to show, let's say, every 20 milliseconds a new trace. And in the spectrogram, we said, higher resolution than 31 microseconds. This is fast enough, otherwise you can't see it anymore. And it's even hard to see there's something already inside, but sometimes it's very helpful to have these fast spectrogram. So, but as I mentioned, we are losing here information inside of the detector. This is not a problem of SignalShark alone. This is a typical problem on real-time spectrum analyzers. And the IQ Analyzer now can change that. When we look into this representation of results in the IQ Analyzer, on the top left, we normally monitor always the spectrum, the real-time spectrum, so that you still have the overview what's going on inside of your spectrum. For example, if your transmitter is changing the channel, then you will can monitor it here directly in the screen, and you can react on it. So what we always have is the real-time spectrum here, including a little blue window, and the inside of this blue window, the IQ Analyzer is acting. So he can make an additional FFT analysis on it, and he can also show the results in the so-called magnitude view. In the magnitude view, you are able to see this signal inside of the blue frame versus time. And here we now can have a 20 nanosecond resolution. Okay, and here we can now set triggers and so on. This was something which was missing in the traditional spectrum analysis. Now we have the magnitude view, and the signal here from the blue window goes into a ring buffer of 1.6 gigabytes, so that we can stop the ring buffer at any time by a trigger or manually or whatever we need. And then we have the results, the IQ data, in a huge memory inside of the ring buffer. And we can analyze it. And what we have inside of the ring buffers are IQ data. So not spectrum, but IQ data. The difference is if you have spectrum inside, for example, by a spectrogram, then we can't change the the resolution bandwidth anymore, or the overlapping of the FFT. This is something which you can't do anymore because you don't have the raw data available. With the IQ data, you can do so. Okay, you can change the overlapping of FFT or change the RBW afterwards because we have the raw data available, which gives us a big benefit. And then we also see the second spectrum analysis of the IQ data, means the signals inside of the blue windows here, and you can reduce or widen here the RBW, making a second spectrum analysis. Plus, we also have the spectrogram, but now with a full resolution of the IQ data, not anymore compressed. Okay. So to show you the capabilities of an IQ analyzer and the high frequency and time resolution, I've prepared a little experiment with a DAB signal. DAB means digital audio broadcast, and here we are now in the traditional real-time spectrum with a typical setting of a span of 20 megahertz, resolution bandwidth 50 kilohertz. Only set it at the measurement time to the maximum speed. The maximum speed in terms of the setting is 250 microseconds. So that means every line here on the spectrogram represents 250 microseconds. And you can see it already. We have three systems, three DAB systems here inside of our screen. And what we can also see that sometimes here in the center system, you can just see it, there is a little gap inside of the transmission. This is for synchronization purpose of DAB. And such kind of signal we can use to show you the capabilities of a real-time spectrum analyzer. I start the video and you can see frequently the gaps inside of the spectrum. And now, as we don't have a trigger here, I can stop the analyzer manually. And now I go into the spectrogram, and now we can see here the gap. And I would like to set now a walk with the marker into such a gap. And you can see when we are walking over the time information, you can see the spectrum here accordingly. Okay. And now we go directly into the gap. I pause here the replay. I can go directly and into the pause of the transmission. And now we see the signal inside of the pause. There are still some carriers inside, which can be normal for DAB signals. Okay. So you can see also that those two signals on the left-hand and right-hand side, they are at the same timing. But you can see that we can now look into this gap, but not very deep, not very clear, because the gap is maybe 2 or 3 spectrum frames long, not more. So let's try to see the equivalent now with the real-time spectrum analysis. So this is here. With the IQ analyzer. So I stop here the video again for a little second. So on the left-hand side, we still have our real-time spectrum, and you can see the blue window is accordingly. So I wanted to make the same setting as we had in real time, but now with the IQ analyzer. Here we have the spectrum view and the second spectrum analysis, which is nearly equivalent. Okay. Here we have the time information, and you can see already here at around about 45 microseconds, there is this little gap. And here we have the high resolution spectrogram. So let's continue with our little video. You can see channel bandwidth is 20 megahertz, resolution bandwidth is around about 50 kilohertz. And now let's go into the high resolution spectrogram. Going to, at the moment, our marker is located at 25 microseconds, but the gap is at around about 45 microseconds. So I direct the marker to 45 milliseconds, not microseconds. Okay, and now you can see already that here for our system there is a much longer um, pause. And now I've set the IQ spectrogram to the full screen, and comparing it to the representation in the spectrogram of the real-time spectrum, and now inside of the IQ analyzer, I pause it here again, you can see that the gap now is much wider, and we can see if there is something inside, we can see it in much more detail. Okay, so it's more than a factor of 5 that we can see here with full resolution. Okay, so the IQ analyzer gives us a possibility to have much more frames of the spectrogram on the screen and to see much better into those synchronization gaps. Okay, let's go to the next example, which is an LTE signal. Okay, you can see we have here an LTE service, which is around about 10 megahertz broad, and here we can see the spectrogram. Again, the measurement time has been set to maximum, and if I start now the video, you can see that it is always red here. There is no framework nearly visible, and here also the peak value is always on top. So as there is so much information and many telephone calls, and we can't see anything of the framework here. Now let's do the equivalent also with the IQ analyzer. And what you can see here is directly afterwards, I pause now the replay again. We can see here the real-time spectrum again. The blue window is nearly accordingly to the bandwidth. We can now see how occupied the channel is, very much. And with a trigger, or as I did it just manually, you can click now into an area where there is a little bit less communication. And then you see really the grid of the framing structure of an LTE signal. This was not possible with a normal spectrum analysis. This is only possible with the IQ analyzer. And here you can even see these block information, the spectrum accordingly to it. So we have now a much higher resolution in our spectrogram, and we have a second possibility to now look into this framing structure. And if there is now a signal under it, we can see it. So I made now the spectrogram a little bit bigger, and I've also put on an interferer at 805 megahertz, and you can see it now here when you look into one area where we can see only the framework, because for some microseconds there is no communication. Then you can see the interferer very clearly here at 805 megahertz. So this is a signal under signal which will normally disappear inside of the real-time spectrum. Even if we change now a little bit the frequency of our interferer, you will be able to see it. I didn't try out the trigger here at that moment, but normally it should be also possible with trigger function. And I would like to compare it also again against the traditional spectrum. Now you can see the frequency has been changed to 807 megahertz, now at 809 megahertz, but we still have the possibility to see it. And what is also very important is the IQ analyzer here in the SignalShark runs parallel to the operating mode. So it's not just I take a sample and put it into the memory and then I make the IQ analysis. This is something which happens really real time, so at the same time. This is very important so that you can really see what is the result of the IQ analyzer, and did I set, for example, the level of the trigger correctly, and so on. So this is really working in real time. So coming back again to the real-time spectrum analysis, and you can see nothing is visible, also not our interferer. So I mentioned it already, the persistence should make it visible. And at the moment you see there is nothing. There is nothing to see inside of the spectrogram. There is nearly nothing to see inside of the persistence. Now I switch on again my interferer. Here it is at 805 megahertz. You see in the traditional spectrogram with a time resolution, which is already high, 250 microseconds is high, but you can't see it because there is too much information going over the network, but in persistence you can see it. Okay, so that means with the IQ analyzer you now get a second tool to find signals under signals. Okay, persistence is one of them. The IQ analyzer is now an additional possibility. You can see now that frequency is changing of the interferer. So the third example is a traditional garage door opener as an example for a sporadic or hopping interference. Up to now, we didn't use the trigger. Now, first of all, I want to show you the garage door opener at 27 megahertz with a manual trigger when I push the run button. Okay, I replay the video, and now I push the garage door opener, and there was for a short second there was the garage door opener. I replay the video again. Be aware, and here there was this effect, but it's gone. Okay, the only thing which can help here is a trigger, which we have in the IQ analyzer or in the traditional spectrogram to set the frames to, in our example, to 10,000. So that means I'm having in my buffer 10,000 spectrum lines, and if I replay it like here, then I can go into the spectrum. I enlarge it and I go into the spectrum and go back inside of my spectrogram, okay? And then after a while I will see it. So this is much more, easier inside of the IQ analyzer, because there we can set a trigger and let him stop whenever it's necessary. So here you can see the garage door opener, this event. But I believe you don't want to sit in front of your analyzer and push manually the start-stop button. So let's do the equivalent with the IQ analyzer. Okay, here again we have our spectrum. At the moment there is silence, and we will only look into the spectrum at this part. So here is a second spectrum. Here we have the time information, and here we have the spectrogram. So let's play the video. I push, first I have to set the trigger. So we have here single mode trigger. We just want a single shot. We want to have a little bit trigger offset of 10 milliseconds. Action is also very important. What should happen when the trigger happens? You don't want to watch the instrument all the time. Actions can be, for example, to store a screenshot or to store the results of the screen. Okay. Here you can switch on the trigger and you can make a manual trigger. And here the type of trigger can be level, can be SCPI, can be time, and so on. So here you set the way of triggering. Here you can enable the way of triggering. And here you set, for example, for level trigger, the level at minus 60 dBm. So it means here a little bit above the noise. And the trigger slope should be rising. So I continue with my little video. All done. So that means I can now switch on armed. And when I push now the button of the remote control, click, I now can see here, I've switched on here a maximum peak to keep here auto record. Here in the magnitude, it's frozen. You can see the trigger point on the time axis, and here it was triggered, minus 10 milliseconds to see also what happened before. And here is now the sequence, and here you can see the equivalent result in the spectrogram. It looks a little bit equivalent like we had it before in the real-time spectrum analysis, but now we can also zoom inside and make it larger and change, for example, the overlapping. Okay, this is not possible in traditional spectrogram. We can change the overlapping to 87.5% so that we have a higher time resolution. We can even change the RBW. Did I do it? Yes. You can reduce the RBW. And remember, inside you're chasing for an unknown signal. So you don't know how to make the best settings. If you have the IQ data inside of your memory, you can optimize the setting. Okay, so this is a big advantage of the IQ analyzer in this case. No, in every case. Here, as a third example, a walkie-talkie is trying to find its correct frequency. So you can see the spectrogram. Again, we had a little pre-trigger, and you can see when the walkie-talkie is switched on, it's disturbing a little bit the neighbor channel. Not very much. This walkie-talkie is quite okay. It's just some kilohertz deviation, but you can see how it's trying to find its correct frequency. The PLL is operating here. And if you have now a faulty walkie-talkie, then it can disturb, for example, the neighbor channel every time when you push the PTT button. Okay, so here we need the two capabilities of the IQ analyzer of SignalShark. First of all, the trigger to trigger onto a single event, and also the high time resolution to see how the PLL or how the oscillator of the walkie-talkie is settling. So now maybe one question will pop up inside of the chat already. What about time-gated measurements? For example, TDD uplinks. So you can see with the IQ analyzer, we now have the base for triggering for the IQ data and so on. So the TDD uplink, so that means that time-gated measurement will be available, I hope very soon. Hope during the next webinar we are doing, I can also show you a preview or better release or whatever of the TDD uplink measurement, all the time-gated spectrum measurements, so that you can do, for example, interference finding during your base station is not transmitting when the mobile phones are allowed to transmit. Okay, this was a question which pops up frequently. And some additional hints about the IQ analyzer. If you have already a SignalShark, there is not much to do. You don't have to return it into the factory because all hardware is already on board, even from the first A series. What was missing was the software around. This is now available on our homepage for downloading. And you also need the option key to activate it. So there is no hardware modification necessary, and the firmware or the option can be activated on site or even remotely if you have a remote unit. So the option IQ Analyzer is available as well as for the handheld as well as for the remote or outdoor unit. Just some hints before we go into the next section, the signal analysis. Here is not much I would love to say today because otherwise we will run out of time. But I told you we can give you a helping hand if you are alone inside of your car. Here a feature which is also new to handheld receivers. So as we have a Windows 10 computer on board of the SignalShark, means we can connect it with a traditional USB dongle and connect it to the internet. Okay, it's possible with something you can buy from AliExpress or Amazon. a normal USB dongle for connecting it to a network. And by this, you can run, for example, also a commercially available remote tool like AnyDesk or TeamViewer in the background of the SignalShark. And then a colleague can have a look to your screen directly online, remotely, and see what you are doing. He can even take over control of the analyzer and do it via the mobile phone network. Okay, so this is a big help, and we as Narda already helped a lot of our sales partners and all our customers sometimes also, so that we tell them install or just run the application AnyDesk on your SignalShark and connect it to the internet. Then we are able to look onto your screen and can help you. So if you are not the right expert to make an interpretation of measurement results, this is a very big help. And I don't know how AnyDesk is doing it, but I was even able to help my colleagues in China with looking onto the SignalShark. I don't know how AnyDesk is drilling the hole through the firewall of China, but it's possible. So let's go to automatic location by vehicle. This is also a big plus for the SignalShark. And first of all, let's have a little look what is the traditional view we will have on the SignalShark. So in the left corner, left upper corner, we see the spectrum, and you can see this is a GSM communications channels we are looking here, and we can have here a maximum span of around about 40 megahertz. So we can see here our signals, and we can see, for example, if the taxi you want to chase is changing the channel. Okay, so here we keep the overview, but you also see here a blue line. The blue line means inside of this blue frequency span, we do the direction finding. Okay, so and this can be much more narrow than the view we have here. So to keep here the overview, and here inside the little narrow window, we do the interference finding. What the analyzer is seeing inside of the blue window, we can see here on the bearing, so-called bearing view. Here we see, for example, as a bar graph, the level inside of the blue window. You can see it's at the moment at around about minus 80 dBm. We can set a threshold that we say, so please ignore any result which is below minus whatever, minus 70 dBm, so that he doesn't do bearings on noise signals. We can also tell him, look for the DF quality. If you want to know what DF quality is, have a look to a little application note which you will find onto our homepage. And you can also say, please ignore results for our heat map if the DF quality is less than 40%. And we can even measure the elevation. So the ADFA in combination with the SignalShark is not only measuring X and Y axis, but also the Z axis. Why this is an advantage, we will show you in the same application note as I just mentioned. We see this application note a little bit later. Here you see the direction of the signal, and you can see sometimes he is measuring into directly south, sometimes into north west. I believe this is due to the fact that it's not really on noise here, but I believe there are some BCCHs operating at those frequencies, and they are quite at around about the same level. That's why he is jumping here always. So, and finally, we have here the map representation. This is not an online map. This is a map which is stored directly on the SignalShark. And at the red point, we can see where we are located at the moment. The black pointer is showing you the direction in which the ADFA is showing at the moment, and also the car is showing. And the red line here is indicating where he gets his bearing from. And we know that the BCCH we want to hunt is somewhere here in the north of Stuttgart. So now let's change over and is this? No, I'm a little bit puzzled. So now, yes, that's the next slide. So now let's try and start driving. And you can see we are changing our direction. And now the heat map is already starting to produce heat map results. But to be honest, during the first seconds and minutes, just ignore it. Okay? Because we are still at a single point and it cannot do a proper bearing because for a proper it can do a proper bearing, yes, for sure, but we can't do a triangulation, a real triangulation. But because for a triangulation, you need to take measurement from two different points, which are in a different position. So here at the moment, what the analyzer is telling you, sorry, what the analyzer, I pause the replay of the video a little bit. What the analyzer is telling you is a red, I always call it the red triangle. And this is telling you, the analyzer, I believe, no, I know there is a signal somewhere in the north. I don't know where it is located, but please drive northwards. He already made a location. He is giving you here a location. But in this case, when the triangle is looking like this, the interpretation is drive northwards. What we need is a circle. When the statistic is telling us here is a circle, a red point, then this is more a localization, okay? He's giving us already results for the localization, but as long as we have such a red triangle, an open triangle, please ignore it. So you can also see with the green points, this is where we started, and the black line is telling us the way we've taken. This is very, very helpful, especially when you drive through urban canyons, that you can see where we've been already. Okay. And now we can always have a look here directly onto the screen if the BCCH is popping up. And I always take motorways, if available, or high-speed ways, first of all, to make the first localization. Okay, bearing he is doing already, but localization, therefore we need a measurement from a different direction or from a different position. And now you can see if this is a real interferer, we pass it. And now we can see that the red triangle is changing into a circle. Okay, and now he's getting here a very, very stable indication. This means we should change direction in driving. So what I now need is a zoom out. For sure you can do it during localization. So where is my zoom out? Then we can see the red dot much more easy. So I pause the replay. Now you can see by zoom out, here is now a red dot and the red triangle disappeared. And now we can say that the statistic tells us here inside of this area, there should be the interference. And now I believe this point here, okay? You see, we came from the south, made all this way, and in the moment when we passed the transmitter, he got information from this point and from this point, and now he can make a correct triangulation, and he can tell us, here is my object, the base station. Okay, what you can also see is we are here together, two people inside of the car, in reality 3 people because I had the camera with me on the rear seat, and we are also using a mobile phone as a navigation system, and this is something I would like to show you some seconds later in our video. Here we go. Sorry, I clicked onto the wrong point. Where is it? here it is. So I pause the video. This is a screenshot from our mobile phone. And there we had a commercially available navigation system running. And this special software is available to accept targets to drive to from external. And with a little Python script installed free of charge on the SignalShark, we can transmit this localization result to the mobile phone, which are connected via Wi-Fi to each other, and we can hand over the position of our measured localization result to the navigation system to be the target for our driving. So that means when you are alone inside of your car, the navigation system can send you directly to the location of the interferer, which is very, very helpful. And in many, many countries, the only legal way for interference hunting if you're alone. You should not have one eye on the SignalShark and the second eye onto the road. But here you have, with all features of a navigation system, a guidance to the target. Okay. So I skip it here a little bit so you can see we've been driving around to make 100% correct result to be sure that it is inside of this building. Okay. Here I switch over to the next point, which is the manual location, because with the automatic antenna, for sure, you can find out which building it is, but you can't see which apartment it is, for example. And this is something we can do by foot now. So you can take the same SignalShark, you just disconnect the automatic antenna, as I do. Then you put the SignalShark around your neck for being comfortable. And now I go again to the trunk and take the second case, the case of the SignalShark itself, and I take out the cable of the handle. The handle has a 3-dimensional compass on board and a little preamplifier. So I can take out the handle and then I can attach, in this case, a lock pair antenna to the handle so that we can now go for manual chasing for the interferer. Now I enter the building, and every time when you are able to change the direction, you wipe a little bit around, for example, with a stone search to try to find the correct direction. Straight, left, right, wherever, straight. Okay, then you go to the stairs. You want to find out, is it here on ground floor or upper floor? Okay, you have to go upstairs, and so on. So this is a traditional way of searching for an interferer. Okay, or you take the elevator and press every button for every floor, and whenever the door is opening, you watch the level, the floor where the level is highest. This is your floor where you have to search for the apartment. Okay, so this was manual localization, for example, by tone search. The last point is the post-evaluation, or let's say also the documentation. And here my favorite thing is a screen recorder. When I do such kind of interference finding, I always have a screen recorder, a standard Windows screen recorder running on my SignalShark, which can record whatever happens directly onto the screen. For sure, also the SignalShark is memorizing all the results, all the screenshots or whatever you need, but I always record in parallel the video, which happens directly on the screen. Plus, the SignalShark also has an onboard microphone so that he can also record your voice. So afterwards, I have the entire work I did as measurement result in the memory or as a video directly with a screen recorder, which I can replay on my computer or even just on the SignalShark itself. Okay, so by this, it's very easy, for example, to train your colleagues to show them samples, how you did it. You can document your work. you can share results even through the internet, or as I do it today here with you. You can impress your boss what you did and how easy it was able to find the signal, or you can even replay them directly on the SignalShark to see them again. What did you do at that time? Okay. So I'm using OBS Studio, for example, but you can also use Snagit or whatever is available as a standard Windows tool for video recording. Okay. So again, this is a big plus of the SignalShark, that you can install such kind of tools directly on the SignalShark itself. There is no additional cable needed or computer needed. You can do everything directly on, nearly everything directly on the SignalShark. So challenging signal properties we discussed, and I've shown you a little bit how the IQ Analyzer today can help you additionally. So we now have a second possibility to show signals under signals, for example. All the other features, there are other videos available on our YouTube channels, and there is also a training available where you get, just try it out. Okay, ask your sales partner for a SignalShark and try it out. Okay, it makes a lot of fun to work with the SignalShark. Challenging reception condition, you say, how can SignalShark help us here? So if you do such kind of heat map as we see it here on the right hand side, the heat map is a statistical process, for example, and reflections will disappear when you drive through a city, because they will pop up and disappear again on such a screen, due to the fact that when you drive through a city, the reflections change their location, because at one point it's reflected by building A, at the second point it's reflected by building B, but the interferer will stay at the same point, but not the reflection. Okay, so the reflection will disappear here by the statistical process of the heat map, and as more bearings you take, as faster they disappear. And SignalShark can do a bearing within a little bit more than a millisecond, so it's around about 800, 900 measurement results per second. The statistical process will show you very easily that this was a reflection and not the real interferer. Okay, so even in those challenging reception conditions, SignalShark can help you a lot. In terms of working conditions, so when you are alone inside of your cars, I've shown you have the possibility for so-called autopilot, so that you just have to listen to your navigation system. And if you are not the real expert, for example, to ask somebody to look onto your screen in real time. Okay, and for documentation, you have the video in the background. So everything runs with additional or not much additional effort. So everything I told you now is more or less marketing, and we also made some comparisons against other products available on the market. And as we are the manufacturer of the SignalShark, maybe you would say, they are biased because you are the manufacturer. We have also some unbiased test reports, and we are very proud of them, because our German agency in charge of interference, the Bundesnetzagentur, they tested the SignalShark itself. They tested the SignalShark in combination with the Decodio software to create a TDOA system, and they also tested the automatic direction finding antennas. Okay, and they have written 3 reports, and they give us the allowance to publish those measurement reports on our homepage. So you can download them from our homepage and see what other customers told us about the SignalShark. So very interesting. And for example, for the combination of with the Decodio software, they said this is the best we ever seen in TDOA. So I've told you the interference finding with the heat map is ideal for signal which is not changing its location, but what about a signal which is changing its location? For example, a taxi, or very popular in Germany is it today to disturb a protest by having a bicycle driver who has a jammer in a backpack, and he is driving around the protest, and he is disturbing with his jammer the communication of the Tetra network. So disturbing the communication of the police. This is not longer funny. This is completely illegal and dangerous, because he's not only disturbing the police, he's also disturbing maybe also the helping hands, the Red Cross and so on. So there we said we need something which is very, very agile and which can change very quickly the location. And so we have a Python script which you can download for free from our homepage, where we set two SignalSharks into the possibility to communicate to each other, and one is taking over the lead, and the second one is responding with results. So you connect two SignalSharks via the internet, as I've shown you, with a little dongles with two little modems. And one SignalShark who has a lead is asking the second SignalShark, which can be also a fixed station, but can be also a mobile station, for its current position and for its current bearing. And then the SignalShark with the lead is taking his own bearing, and his own position, and making directly a triangulation out of this and showing the result directly on the screen of the SignalShark. So if now the target is moving, you can chase him, really. And what you need is two SignalShark with automatic antennas and two LTE modems. That's it. You don't need a special software around. You don't need a big system or a computer. This is really possible just with two SignalSharks and two ADFA. A very agile mini system, which is, I believe, also the future of interference finding. So another example for scripting is, for example, Python scripting is, for example, coverage map, which can be done easily with a SignalShark, because he is recording its position and drawing such a map directly onto the map on the SignalShark, or export the values directly to Google. Okay, so this is a script free of charge on our homepage. Not free of charge, they cost some money, are software for deeper analysis of signals. So we, as a private person, or a commercial active person, we are not allowed, for example, to go into deep details of PMR signals. But if you are in charge, if you are a member of the police, then you have the possibility to look also into the metadata of Tetra, Tetrapol, UPCO, P25, or whatever is on air. Okay, so if you need something for classification and decoding those kind of signals, and you have the license to do so, you can choose, for example, Procytec software, or you can choose Decodio software. And then depending on the bandwidth you are using, you can even install it directly on the SignalShark and make, for example, signal analysis like demodulation, listening in, recording, measurement, burst duration, zero crossing, and all these things you are now able to do with such kind of analysis software. So, and I mentioned it, this can even run with small bandwidth. It can even run directly on the SignalShark itself. You don't need an additional computer for doing so. Okay, you just attach the dongle of Decodio and install the software directly onto the SignalShark and go. I mentioned TDUA. SignalShark is also prepared to do a TDUA measurements inside of systems, and here an example with a Decodio software, and you can see the red lines, which are the hyperbolas for the TDUA measurement, and you can see here the location. Plus, one of the station is also equipped with an automatic antenna, so you can even do hybrid localization with SignalShark and antennas and the software like, for example, Decodio Rex. Okay, and those stations don't need an external PC because they can communicate with the base stations just by an LTE dongle, for example, and they can be battery operated. So you can even set up a mobile system on bicycles with these kind of analyzers. Okay. I mentioned an application note where you can read more about what does it mean quality of bearing and why is the measurement of the z-axis important. We have here a little brochure or application note available on our homepage where you can read more about it. There's also one document which is called FAQ, Frequently Asked Questions. And there we summarized all the questions which popped up during the webinars and also in our service center. And we've written down all the questions. We neutralized them. There is no personal information inside. We neutralized them and we added the answer to your questions. And at the moment, this little document has around about 29 pages full of information. A lot of application things, so you can download it for free on the SignalShark homepage or our homepage. So the FAQ documents, we have tons of YouTube videos there. We have news via our news blog or LinkedIn. Don't forget to subscribe. And for sure, there's also training available for the SignalShark to train you here in Germany or if necessary on site. Okay, if it makes more sense to go to whichever country and to train you there. Okay, that's it from my side, a little bit over time.